My name is Amy Dalmas, a student in George Mason University's Health Informatics 671 course. This session will provide an overview of how to build an Entity Relationship Diagram, or ERD, using a lab ordering example. First, I'll summarize the basics of ERDs. Then, I'll demonstrate building an ERD for a simple lab ordering example. I'll close out by reviewing ERD challenges, best practices, and tools. What is an ERD? This slide has three simple definitions. Basically, an ERD is a visual model to describe data in a way that translates business rules into database design. ERDs matter because they can be used to ensure that clinical workflows are accurate and help prevent data mistakes that could impact patient care. They also help us meet regulatory requirements by supporting interoperability, secure access, and audit readiness. And from a business angle, they cut down on rework and make it easier to scale future projects. There are four elements of an ERD: entities, attributes, relationships, and cardinality. Entities are basically the things we care about, like patients, appointments, or medications. Attributes are the details about those things, like a patient's name or an appointment date. Entities and attributes are depicted on ERDs using either shapes or tables. Relationships show how entities connect to each other in the real world. And cardinality tells us the rules of those connections, like whether something is one-to-one, one-to-many, or many-to-many. Cardinality can be depicted with numbers, like the Unified Model Language format, or with images, like crow's foot notation. Put together, these pieces give us a clear picture of how data actually works in the system. Now that we know the basics, let's design a simple ERD. First, we need to understand the business needs. This slide shows a common requirements gathering method called a user story. In this user story, we are describing the need for a database that supports the process of ordering lab tests. We've talked with our system users and defined the criteria for this database to be accepted as useful in their workflow. For instance, providers can search and select one or more lab tests, and providers can submit a lab order. Now, we'll search for our entities in these requirements by highlighting the nouns in the write-up. The nouns represent the people, places, and things that we want to capture data about. In our example, we have people like the provider and the patient. We have a physical place representing external labs where tests can be performed. And we have things like tests, specimens, orders, and results that we want to process in our database. These nouns are a good place to start when identifying entities. Next, we need to identify the relationships between entities. We do this by describing the verbs or the actions that the entities perform. For instance, a patient provides a specimen. A provider collects that specimen. Using a similar approach, we define the actions that form the relationships across all of our entities. At this point, we've created a conceptual model that depicts entities and relationships in simple terms understandable by our customers or business stakeholders. This conceptual model can be used to validate our understanding of user requirements before we expand the ERD in the next steps. Now we'll look further at each relationship to define cardinalities. Let's look at the relationship between patient and specimen, for example. When ordering a lab, a patient can provide one or many specimens. For instance, a patient may provide both a nasal swab and a blood specimen for a COVID respiratory panel. So we'll mark the relationship from patient to specimen as one-to-many using crow's foot notation. Let's consider the reverse. A specimen can only belong to one patient. So the relationship from specimen to patient is one and only one. Here is a sample of our lab ordering database with cardinalities added. This diagram was created in a tool called Mermaid. I'll share more tools at the end of this presentation. Next, we want to build out our model by adding attributes for each entity. Attributes are the details that describe an entity. Each entity must have a primary key. A primary key is an attribute or set of attributes that uniquely defines a single record in the entity. In our example, patient ID is the primary key of the patient table, and specimen ID is the primary key of the specimen table. We may also have one or more foreign keys. A foreign key is a field in one table that refers to the primary key in another. For example, we said that a specimen belongs to one patient, so we can add patient ID as a foreign key in the specimen table to link a specimen to a patient. Other attributes can be descriptive fields, like name and date of birth of a patient, or specimen type and collection date for a specimen. We can also discover more foreign keys as we expand our entities. For instance, say we find out that we have an address entity that already exists in our database. We can add an address ID foreign key to link a patient to their address. Now that we've added cardinality to our relationships and attributes to our entities, we have what's known as a logical ERD. This logical ERD was built using a tool called Lucidchart. A logical ERD is still in a format where business analysts and even end users can verify our understanding of the clinical workflow. And now it is also in a format where a database administrator can analyze it for building the physical tables and fields in the database. Sometimes you will work further with the database administrator to build a physical ERD, which expands this model to include data types and constraints to actually build the database. But for the most part, as an informaticist, you'll be responsible for getting to a well-designed logical ERD like the one shown on this slide. To wrap up, let's briefly discuss challenges, best practices, and tools for ERDs. When you're building an ERD, two of the biggest trouble spots are incorrect relationship definitions and scalability problems. Let's look at our order and test entities from our lab ordering system example. Say that we make a one-to-many relationship between order and test. So an order can contain many tests, but a test can only belong to one order. In practice, this means a brand new test record has to be created every time someone places it on an order. For common tests like an A1C test, there may be hundreds or even thousands of orders generated in a year. If a new test record has to be created for each new order, that would result in thousands of nearly identical A1C rows, causing the test table to get huge, slow, and messy. A better design would have a many-to-many relationship between order and test. An order can have many tests. One test can belong to many orders. However, complex many-to-many relationships may also cause an issue. Even though relational databases can handle many-to-many relationships, they can't store them directly. So oftentimes a junction table, like an order test table in this example, is created to resolve the many-to-many relationships. Some best practices to keep in mind when creating ERDs include the following. First, keep it simple, especially at the start. The main function of an ERD is to translate business rules into technical design. So your resulting ERD should be at a level where business users can easily confirm the logic. Second, use a standard notation. Whether you choose a graphical notation, table notation, unified language model, crow's foot cardinality, or other, keep it consistent throughout your design. Next, define clear relationships and use meaningful naming conventions. It can help to write out your database design in simple sentences using nouns and verbs like we did in our example. This makes it easier to confirm database decisions with both business and technical stakeholders. And finally, iterate and refine. An ERD is rarely a once-and-done activity. You will likely go through a few iterations to refine the design both for the business logic and for technical feasibility. There are a number of tools that have templates for drawing ERDs. Some tools that have free or student versions available are listed on this slide. I showed examples of ERDs from Mermaid and Lucidchart in this presentation. Draw.io, SmartDraw, and ERD Plus are some other popular options. Here are the references I used in the creation of this presentation. Thank you for listening to my presentation. I hope that this has given you a good overview of entity relationship diagrams, how to build them, and why they are useful in health IT database design.